ShinDiggers, thanks for joining me here today at Dinosaur National Monument. My name is Rebecca Hunt Foster and I'm the paleontologist here. And today I thought I would show you a little bit around the Carnegie Quarry. We have lots of these really large fossils that are easy to see from far away. But today I wanted to show you some more of the small, more uncommon fossils that maybe you can't see when you're visiting the quarry without getting up close and personal.
150 million years ago, this area was once home to an ancient river that flowed across a vast plain. Vegetation was likely abundant on the margins of this river, with the riparian habitat providing a rich place for the late Jurassic animals to thrive. Then a long drought killed many of these animals. Some dinosaur bodies lay in or near this now dry river channel. When the extensive rains returned, floods swept many of these carcasses up. The fast-flowing river carried the bones downstream along the river. As floodwaters receded, the river slowed. The bones dropped out of the water and onto the river bottom and began to pile up. They were covered up by sand and mud, resulting in the logjam we now see preserved at Dinosaur National Monument. Sand buried some of these bones quickly, so the skeletons remained complete. Some of the other bones were scattered over long distances. Around 1,500 bones are present on the quarry wall today from around 500 different individuals. The quarry preserves mostly large dinosaur bones as these large objects move more slowly in a fast-flowing river. Small animals are usually swept away and are often not preserved. Today I would like to show you the remains of some of these smaller fossils that are preserved here in the Carnegie Quarry.
The 150 million year old Morrison sandstone that we find inside the Carnegie Quarry also extends behind me here. You can walk along the fossil discovery trail and look at other fossils that can be seen in the same horizon of sand that we find inside the quarry. Dinosaur National Monument is located in northeastern Utah and northwestern Colorado. The Dinosaur Quarry is located just outside of Ginseng, Utah. The orange you see on this map here represents what we call the Morrison Formation. The Morrison landscape would have been vast and varied. There were abundant lakes, the plains, rivers, deserts, and ponds that covered this area around 146 to 158 million years ago. The dinosaurs that we find here at the quarry include the sauropods Apatosaurus, Barosaurus, Camarasaurus, and Diplodocus. The theropods include Allosaurus, Ceratosaurus, and Torvosaurus, and the ornithischians include Camptosaurus, Dryosaurus, and even Stegosaurus. Other animals that have been found at this site include crocodiles, turtles, clams, insects, plants, and lizards.
On August 17, 1909, Earl Douglas, a paleontologist at the Carnegie Museum, and Elder Goodrich, a Vernal, Utah local, are credited with the first documented discovery of dinosaur fossils in what would become Dinosaur National Monument. The first 8 bones discovered were determined to be from a new dinosaur, later named Apatosaurus louisii, after Andrew Carnegie's wife. Carnegie funded the majority of the early excavations that took place at Dinosaur National Monument. This original Apatosaurus skeleton can still be seen today at the Carnegie Museum of Natural History in Pittsburgh, Pennsylvania. Pop Kay, originally a resident of the Uinta Basin, joined Earl Douglas in the excavations at the Carnegie Quarry. In 1917, Jesse York, Pop's 10-year-old brother-in-law, visited the quarry to help with various projects. Pop had Jesse work on drilling a blast hole in the nearby sandstone. After it was dug to a depth of 4 inches, Pop placed a small charge of powder, a blasting cap, and detonated the explosives. Afterwards, Pop, Jesse, and a few other workers began looking around the debris and were surprised when someone found a part of a small skeleton in a block. Hours later, the other piece turned up in the debris and it fit perfectly onto the other piece collected earlier. After having been cleaned, the specimen measured 7 inches total length and was revealed to preserve a small, full-grown crocodile with a skull, limbs, vertebrae, and armor that are all present and three-dimensionally preserved. In 1926, Gilmore described this specimen, naming it Hoploseuchus ki, honoring Pop K. Even a century after its discovery, Hoploseuchus is one of the most complete and well-preserved small vertebrate skeletons ever found anywhere in the Morrison Formation. The conical pointed teeth indicate that it probably ate insects and small vertebrates. Here we have a scute, or one of the bony armored pieces from the back of a freshwater crocodile. These would have been abundant in these river channels, but we don't find many of their remains here. This unionid clam is an invertebrate fossil, and this invertebrate fossil is one of the most common fossils that we find here at the Carnegie Quarry. This fossil is important because, as you can see, it's open, and this tells us that the area was undergoing a drought. If this clam was closed, that would tell us that it was probably a wetter time. These animals also need clear, fresh water in order to survive. They would attach themselves when they're larvae to the inside of fish gills in order to travel up river drainages. And that's another indicator that tells us that this area used to have long-term water. It would have had a river. It wasn't just random flood events. So these clam fossils are one of the most important keys to help deciphering why we have so many fossils preserved here at Dinosaur National Monument. Here you can see two different types of turtles, Dinocheles on the left and Glyptops on the right. Both are relatives of modern-day pond and river turtles, and we have found both adult and juvenile forms on the Carnegie Wall. Dinocheles has a smoother outer shell surface and is slightly more elongate than Glyptops, which is more widespread. The Dinocheles specimen preserves both a tail, a neck, a leg, and a foot. Shells are relatively common in the fossil record, but often these other bones are not. Here you can see the articulated foot of Dinocheles. When we look at these juvenile specimens of Dinocheles and Glyptops, you can see their shells are far more ornamental than those of the adults. When we look at the underside of this Dinocheles specimen, we can see this foot preserved, as well as the leg. When we look at the underneath of this complete Glyptop shell, this small triangle here indicates to us that this specimen was not fully grown. A sphenodonid jaw similar to this one was found in the quarry, but occurred only as a natural mold in the pebbly sandstone of the river. This single microvertebrate fossil from the site represents a sphenodonid, close to Opisthius, possibly Opisthius itself, which has been found elsewhere in the monument, although it's hard to tell from the mold. It was probably insectivorous and partially herbivorous. Sphenodonids are lizard-like reptiles that can get up to 2 feet long and live for up to 120 years. They are represented by the tuatara today, but during the Mesozoic they were much more widespread and diverse, with large, fully herbivorous and also semi-aquatic species known from the Morrison and other formations. Behind me you can see a long black mark on the quarry wall. This is the remains of a carbonized log, and it's actually a reasonably small log compared to some of the logs we find in the Morrison Formation. These large trees suggest that perhaps the land was not quite as arid as once believed. Here we have a Dryosaurus femur. We can tell it's a Dryosaurus by this large fourth trochanter that kind of sticks out here, almost like a can opener. This is probably a young individual. In this area we also have a young Diplodocus that you can see. And then these sauropod, ulna and radius below me here are also covered in borings from a dermestid beetle larvae. And these things were probably chewing down through the carcass, and occasionally they would hit the bone and leave these little pock marks. This area of the quarry has a lot of Stegosaurus material. Here you can see a large plate, some caudal or tail vertebra, and then this is what we call a nuchal plate. This would have been one of the plates that would have been on the neck of Stegosaurus. This is one of my favorite fossils on the wall. Here we have a folded up leg of an Allosaurus. So what you can see here is the femur, the tibia, and the fibula. And then these are the metatarsals of the foot.
and the different toe bones. And when we look closely, we can even see a claw still in place. So this leg is basically folded up just as it would have been in life if it was rested. Here we have a sauropod hand claw. You can even see the groove going along the side here. These things would have been covered in a keratinous sheet in life, just like our own nails are. Here we have two sauropod hindfoot claws. Again, you can see that groove. Another rare dinosaur that we get here on the quarry wall would be Camptosaurus. And here you can see the jaw of the Camptosaur. It has several teeth still in place. This Camptosaur was recently found to be a new species. We also have other Camptosaur jaws that can be found on the quarry wall, pictured here. Teeth like this large Allosaurus tooth can be found on the quarry wall when you're up close and looking, but from a distance they're really hard to spot. Even on this tooth you can still see the serrations, and it's in pretty good shape for something that's embedded basically in gravel. And here we have a Camarasaurus tooth. The reason we have so many of these teeth loose is that these dinosaurs are losing their teeth throughout life. Whenever one would fall out, another one would just replace it. Even these slender diplodocene teeth can be found along the wall.
Barosaurus is a relatively rare sauropod dinosaur, similar to Diplodocus, except for it has very long cervical vertebrae, 9 dorsals instead of 10, and a few other minor differences. The first specimen was found in 1889 in Piedmont, South Dakota, north of Rapid City, and named by O.C. Marsh in 1890. Marsh later sent George Weiland to collect the rest of the specimen in 1898, leading to the discovery of the very long cervical vertebrae. Several specimens are known from Dinosaur National Monument, including the specimen on display at the American Museum of Natural History, as well as a recently described juvenile specimen.
This Stegosaurus was found here at the Carnegie Quarry in the 1970s. This Stegosaurus is really important because not only is it the smallest Stegosaurus that's ever been found anywhere in the world, it's also the most complete baby Stegosaur that's ever been found. When we think about Stegosaurus as a group, we know that it had lots of cousins that lived elsewhere in the world. But Stegosaurus that lived here in North America is the only member of that group that's ever been found to have baby fossils. We haven't found their eggs and we haven't found their nests, so we really aren't sure how they maybe cared for baby Stegosaurus, but we do have several specimens. This specimen preserves the front and back legs, part of the hips, and some of the ribs. What it doesn't preserve would be the skull, many of the vertebrae, or any of the plates or spikes on the tail. So how do we know that it even had plates or spikes on its tail? Well, another specimen of a young stegosaur was found in Colorado, and on that specimen they actually found little Stegosaurus plates. So here you can see a replica of one of those small Stegosaurus plates. It's somewhat triangular, just like the grown-ups are, it's just much smaller. So this tells us that yes, baby Stegosaurs would have had small plates on their back. So today I've brought an example of one of the real Stegosaur upper leg bones, or the femur, so that you can see what the real bone itself looks like. And these are what the other bones in the museum collections look like as well. You can see the upper leg bones, the lower leg bones, as well as the arms and some of those ribs. Here you can see the scapula of a large adult Stegosaurus. Here we have the scapula of the baby Stegosaurus that was found here at the Carnegie Quarry. You can see there's definitely a size difference. When we look around the quarry wall, we start to see that there's actually quite a bit of juvenile material that can be found, such as this neck vertebra from a small sauropod. And here's an adult cervical. A juvenile ilium, a juvenile cervical, and a juvenile humerus. Juvenile ischium. Here we have a juvenile sauropod tibia, fibula, astragalus, and calcaneum. Juvenile femur. Scapula. Here's another femur and another one. This one has tooth marks on it. And there's even a scapula. They're everywhere.
More than a third of sauropods in the Carnegie Quarry are juveniles, here defined as specimens that are less than 50% average adult size in linear dimensions. This is almost exactly the ratio of juveniles that you see for sauropods in the Morrison Formation overall. Within each sauropod genus known from the quarry, anywhere between just over a quarter and up to 1/2 of the minimum number of individuals are juveniles, including half of all known Diplodocus specimens. Looking at the overall sample from the Carnegie Quarry, more than half of the specimens are accounted for in the 4 sauropod genera. Crocodiles, turtles, and the sphenodontids account for about 14% of the total, while stegosaurs, ornithopods, and theropods account for the remaining 28%. But at 14%, the smaller non-dinosaurian elements of the fauna are still a significant component.
Thanks again for joining me here today at Dinosaur National Monument to learn more about little bitty fossils that we have here on the quarry wall. Hope to see you next time in Ekalaka. Until then, take care. Thanks.